Welcome to all. I am continuing questions now. See, today we will solve around 4-5 questions. All small questions. All are concept-based questions. Small questions only, but solve all these questions, good idea will come. See, last class, some checking logic was involved. Today, no logic, directly question given. As I give the question, I will tell what is in the mind of the person who said the question. Okay. A block, see, everything, see, all these questions on friction, small questions, usually I write before explaining because time saving. No, because these are all already known to you. Unless it is completely concept based, I will write earlier. But I will explain everything. See, a block weighing 400 Newton is freely placed. I already told you the meaning of freely placed, not once. I told you so many times what is freely placed. Okay, freely placed on a rough inclined plane which makes an angle of 15 degrees with the horizontal. See, rough inclined plane makes an angle of 15 degrees. Then coefficient of friction is 0.4. So this mu is 0.4. You should write them where? Given in the question. See, when you solve, you should write given coefficient of friction is 0.4. Angle of inclination of the inclined plane with horizontal, say theta, is 15 degrees. If you write all these, solution becomes more systematic. Okay, then question is, find what least force is required along the plane, see, along the plane to the block, to be applied to the block, where else? To the block only, to prevent it from sliding down. So I will tell you what is the question. See, the person who said the question, actually me only, maybe it is 15 degree here. He placed a block weighing how much? 400 Newton. In his mind, he thought it will slide down. See, it will slide down. Actually, I know it will not slide down. That we will be knowing later. See, negative sign came. That all I will explain later. You solve as if you solve whatever is given in the question. See, he thought what? It will slide down. So how to prevent slide down? You have to apply a force here along the plane to prevent it from sliding. Least force means it should be on the verge of the, I told already, long back I told 4-5 times, not 4-5, 10-15 times. Whenever least force required, understood that it is a case of limiting friction. This all I told you. See, so therefore the person thought it will slide down. What force is required to prevent it? Okay, solve. Now, somebody may comment. See, 1 minute now. I will tell now only. Suppose this question is an objective question to be solved, and if I am writing examination, see what I will do. See what I will do. See now, what I am going to do. Angle is 15 degrees. Okay. Mu is 0.4. So angle of friction is tan inverse of 0.4. Shift tan inverse 0.4. It is 21.801 degrees. Make a note. This is outside, not now, later. That is, if I am solving the question as an objective question, if I am writing examination, I am not writing any examination. So your angle theta 15 degrees is less than angle of friction. Therefore, this block will not slide. Answer is no force required. That is the conclusion solved. But now, the person who said the question, imagine somebody else, not me. Actually, me only. Okay, start. See, red color I wrote. Let P be the least force required to be applied along the block. See here, least force required to be applied along the block. See, surely it is this way. This way, why? When it is sliding down here, your force should be along the plane like this. The next class we will put some inclined force, or see, when the horizontal force applied, that all will cover one by one later. We will go systematic order. Least force required along the plane to be applied on the block to prevent it from sliding down. Okay, now usual statement, this statement I am not rubbing. Today's all 5 questions, this will be there. Now I will not explain again and again. Let R be the normal reaction. Okay. When the force P is applied, the block will be on the verge of sliding down. Why? Because it is the least force. Little lesser means block will slide. So slide down. Therefore, resisting frictional force on the block will be limiting frictional force FF limit equal to mu into R, 0.4 into R. This I will not explain every time now. This is told more than 100 times. Okay, now consider the block. See, weight acting down 400. Okay, then P applied this way. Block is, you should write all these if you want. Since the block is on the verge of sliding down, friction force is this way. FF limit will come equal to 0.4 R. Then you take, that also you write here. Then you write, let us consider, see, you write, consider reference axis XX along the plane. Every class you will write here, along the plane, and YY perpendicular to the plane, perpendicular or normal to the plane. Usual statement. Okay, XX, YY. Now, see, 15 degree. I already told so many times. Reference axis is this way. So, component along XX will be cos, component along YY will be sin, hundreds of times told, provided you consider the angle with the XX. So, when this is 15 degrees, this is 75 degrees. Y means no answer. Okay, now therefore, if you resolve this 400, cos, sin, explained more than unnecessary, explained more than multiple number of times. If I talk further, it is waste of time. Or if somebody getting confused here means he is not following everything I am telling. He is not studying seriously. He or she not studying seriously. So my class is not ideal for them. Okay, start. Sigma Fy0 upward positive. Plus R, this all I explained. Again, I should not tell now. See, directly, plus R. These two will not be there because these two are directly along the XX. Then, minus 400 sin 75 equal to 0, you will get the value of R. Okay, then, sigma Fx0, take right side this way. Right side means this way positive. Plus P plus 0.4 R minus 400 cos 75 equal to 0. Substitute R equal to 386.370. Your P will come negative. So over negative. Now I am writing the answer here now. You should write here. You should write. I am dictating in the class, but you should write here. See, right. Negative sign indicates that force is not required. First, that means the block which is placed on the inclined plane, first of all, will not slide. When it is not sliding, see, maybe it is like this. It is not sliding. When it is not sliding, why you want to apply a force to prevent it? See, you require the P when it slides down. That is next question. Over. Therefore, right here, negative sign indicates that the block will not slide down when freely placed here. So there is no question of preventing from sliding. You write that statement and close the question. Okay. Question number 37. Okay. Solve now. 37. Same. A block weighing 400 Newton is freely placed on a rough inclined plane which makes an angle of 42 degrees. Okay. 42 degree with horizontal. Okay. Now, same question. Friction coefficient is once again 0.4. I am not changing. Actually, I can change it. But no, you solve independent question. Then, find what least force is required along the plane to be applied for the block to prevent it from sliding down. Okay. Put this sketch. Now, this sketch will be, see, horizontal plane, 42 degrees, see, this way. it is stiff now. This theta equal to 42 degrees. Block is placed here. Oh, this time by looking you can make out, oh, there is a chance the weight of the block is how much? Same 400 Newton. Now if you observe, to the mind, feeling will come. Oh, most probably this will slide. Okay, see now. Okay, solve the question. See, maybe now the question is, see, like this. 42 degrees you are placing here. Oh, see there? Okay, now, I will tell later if I am solving this in a competitive examination without writing, how I will solve, I will tell. Okay, start. Everything same here. So this sketch I have to change now. Why? It looks, this is 15 degrees. Looks very odd. It looks very odd here. I should make it somewhat reasonable. See, the angle should be reasonable. Actually, 1 minute. I'll pause because little wet. It will take some time to get dry. Okay, I have put the sketch here, solved also. Okay, see here. It's stiff angle, same as last time. This angle 48 degrees, if this is 42, 48, this is cos, this is sine. Everything is explained last time. First of all, I should work out sigma fy0 plus r minus 400 sine 48 equal to 0. R will come 297.257 Newton. Sigma fx0 plus p plus 0.4 r, this is not there, minus 400 cos 48 equal to 0. Substitute r 297.257, you will get p plus 148.749. Now write answer. Yes, you can make a small note. Positive sign indicates that yes, to prevent sliding, a force is required. The answer is no plus no. See, the force required to be applied along the plane, that is going upper side. See, up, see, along the plane, up along the plane is 148.745 Newton is the answer. Okay. Now, I will tell if I am solving this one in a competitive examination. Again, remember, I am not going to write any competitive examination, but still, this is for those. See, what I will do, I will check here first. Theta, they told 42 degrees. Not clear. I will make more clear. It rubbed out actually. Theta is 42 degrees. Okay. I will start fresh. Mu is 0.4. Shift tan inverse 0.4. Angle of friction is 21. Oh, this time your angle is too stiff. The angle theta is more than angle of friction. Therefore, this body will 100% slide down. Okay. Therefore, I will put, last time I will stop the question. Last time what happened? I told it will not slide. So no question of preventing it. But this time, yes, it is sliding down. Start. No sketch, nothing. See. Normal reaction R. I will calculate. See. This R and this will balance. So 400 is 400 into sine 48. Normal reaction, I will get 400 into sine 48. 297.257. I will store in memory that number. See, I will store in memory that R. Okay. Then 400 into cos 48. 400 into cos 400 into cos 48. That is the force which will try to slide down. I will subtract the friction force minus 0.4 into that normal reaction. I already stored in memory. Answer coming is 148.749. Yes, I will do this way and tick the answer there without using pen. By only observation, if provided, if the concept is clear, you can do it. Okay, now question number 34, 35 over, 36, 37 over, 38 now. I will write the question and start. This is a new type of question. Little change is there now. Another 3 more questions today. Next question, remember, same statement. See, a block weight, now instead of Newton, I will give in kilonewton. So what? Answer will come in kilonewton. A block weighing 6 kilonewton. I wrote 2 kilonewton there. Okay, 2 kilonewton. I don't know why I put 6 kilonewton here. When I went there, I made it 2 kilonewton. Okay, change the question. A block weighing 2 kilonewton is freely placed on a rough inclined plane which makes an angle of 40 degree with the horizontal. See here, freely placed, weight 2 kilonewton, then coefficient of friction is 0.3. Find what force, least force is required along the plane to be applied to the block to slide it down the plane. Oh, now question is changing. See, in the previous two questions, question number, you should write all these ones. See, 36 and 37, both questions, it was what? The person who said the question, he placed here, he thought it will slide. What force is he thought it will, both the questions he thought it will slide. What force is required to prevent it from sliding? That was previous two question. But of course, what happened? One question, it was not sliding, so not required. Second question answer came, but this time not that way. This time the person who said the question thought that it will not slide. See, he thought like this. Now to slide, what to do? If you want to slide, you have to apply a force, not this way now. This way you have to apply a force now, see. Suppose, imagine a vehicle is parked on an inclined road and with the front brake or brake applied. If it is sliding down, you want to prevent it, you have to apply this way force. But if it is not sliding, it is stationary, and you want to create a mischief. Suppose you want to create a mischief, what you have to do? You have to go to other side and push it down the plane if you want to slide it. So this time the person, this time the person who said the question thought that this will not slide. Okay, now let P be the least force required to be applied along the plane on the block to slide it down. See, to slide it down this way. Again, sliding down, friction is this way. This statement will be once again same. Now 0.4, last time it was 0.4, I made it 0.3. Okay, this all same. See, 40 degree here, 50 degree here. Sigma Fy0 plus R minus 2 sin 50 equal to 0, you get R equal to 1.532 Newton. Sigma Fx0, right side positive. So, minus P plus 0.3 R minus 2 cos 50 equal to 0. Substitute R equal to 1.532. Be careful, correctly simplify. Your P will come minus 0.826 kilonewton. Now, write the answer. Force required to slide it down to apply this way, negative sign came. Negative sign means force is, see, negative sign indicates that there is no force required to slide it down, because that means this block, he thought it, see, the person who thought, said the question thought it will slide down, but actually he will thought what? It will not slide down. He thought it will not slide down. So he want to slide it down. But actually what happened is, as it is only, it is sliding down. See, if a vehicle is parked in the road, if it is already going down, sliding down, why you want to apply a force? Keep quiet. Okay, now, if this is objective question, what I will do is, see, I will come here. First, angle is 40 degrees. Mu 0.3. Shift tan inverse 0.3. Angle of friction is 16.7 degrees. 699 degrees is 16.7 degrees. So, the angle of inclination of the plane is more than angle of friction. So, this block will not be in stable equilibrium. It will slide down. I will tell force is not required. Over. Now, next question. 38. See, what I am doing? 39. See, last time, first question, What force required to prevent from sliding? One question negative came, one question positive came. Now what force is required to slide it down? This question negative came, next question positive will come. See, a block weighing not 2 kg, okay, same 2 kg only. 2 kg only is freely placed on a rough horizontal inclined plane, etc. at an angle of, how much I got? Angle of this one. What angle I got there? Shift tan inverse 0.3 is 16 point something. At an angle of, see, at an angle of 10 degrees with horizontal. Coefficient of friction is 0.3. Find what least force is required along the plane to be applied to the block to slide it down. Now this sketch I have to change it now. I will write it so that, because I can't make, see, I cannot make this way. Somebody will tell, hey, this person does not know what angle. 10 degree means it is like this. So I will put the sketch once again so that it should be real. Now continue. See, it is 10 degree. Actually 10 degrees further lesser, but what will happen is, see, if I put 10 degree like this, see, like this, it won't be clear. So little bigger I am writing. So 10 degree they told. Again same solution. Everything same. What is the question? He thought this will not slide down. So to slide it, how much force is required? Start. Now this is 10 degree, this is 80 degrees. Sigma Fy0, see, plus R minus 2 sin 80 0, R will come 1.970. Sigma Fx0, right side positive, minus P plus 0.3 R minus 2 cos 80 equal to 0. Substitute R equal to 1.970 kilonewton, your P will come positive. Oh yes, right here. Now you write right there. Positive answer came, means correct. You require a force of 0.244 kilonewton to be applied down the plane from that side, or you can apply from here also. Okay, therefore this time correct. Now I will tell, if I am solving in examination, see what I will do. I will not write anything. See, I will only observe here. This sketch only I will observe. 2 into, this is 10 means 80 I can make out. 2 into sin 80. 2 into sin 80 is the normal reaction. I will store in memory. Then that whatever normal reaction is there, see, before that what I will do? This is 10 degree. See, mu is 0.3. Shift tan inverse 0.3 is 16.69 degrees the angle of friction. Oh, this time angle is very small, so body will not slide. You really require a force. I will first check that one. Then I will get the normal reaction here. Then normal reaction into 0.3. See, shift store A into 0.3. I got 0.590. I got 0.590. That is the frictional force. Now, to slide, this W component is there, 2 cos 80. So 2 cos 80 is really sliding. I will subtract 2 into cos 80. I will get the answer 0.2435. 0.244 over. But you don't try this way. If you are writing competitive examination, you correctly write a sketch and solve. Okay, now today's class, last question, 30, 34, 35, 36, 37, 38. 33, 34, 35, 36, 37, 38, 39, 40. Okay, last question 40. In case question number is wrong, you correct it. I think correct 40. This is some other question. See, this time I will fully write the question and solve. This is a new type of question. Now, last question for today's class. Remember now, concept changes now. a block weighing 800 Newton is freely placed on a rough inclined plane which makes an angle of 25 degrees with horizontal. Coefficient of friction is 0.35. Find, see now, what least force is required along the plane to be applied to the block to move the block up the plane. See, to move the block, move, M-O-V-E, I think visible for you. To move the block up the plane. The move is not fully clear there, right here. To, see, to move the block up the plane. This time only one question because now negative cannot come. See, now whether you place, now they want what? Now they, suppose a vehicle is parked in an inclined plane, you want to push up. Now negative cannot come because you have to overcome gravity now and also overcome friction. Now, see, I will not compare theta with angle of friction. I will start solving directly. Common sense, see, something. It does not matter. See, it is placed like this, how much? At an angle of 25 degrees. Maybe it may be sliding. Okay, then no problem. But what he wants, whether it slides or not does not matter. He will place it here and apply a force this way. See, freely placed and then immediately apply a force. Understood? So, therefore, this time question is what? See, now don't compare. Whether it slides down freely does not matter. Now, what you want, see, it is placed like this. See, if it is sliding also no problem. See, now you want to find what force is required to move it up the plane. That is along the road upper side. Completely change. See, all the previous 4 questions, it was sliding down. But now 2 questions were how to prevent sliding. 2 questions are how to slide. Okay. But now how to move it up the plane. Okay. Let P be the least force required to be applied along the plane on the block to move the block up the plane. Now surely force like this. Let etc. all same now. See, resisting frictional force on the block will be FF limit equal to 0.35 R. These all same because why? Least force means what? It is on the verge of moving up. Now make very important statement here. You write here. This time be very, 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 very careful. The purpose of P, I am dictating now, you should write here. The purpose of P is to move the block up the plane. What is the least force required to move it up the plane? So therefore, the tendency of the block is to move up the plane. When you try to move up the plane, the friction will be reversed. See here. See, whenever, see, make a note. If any block is sliding down, friction is this way. But if you move it this way, friction is opposite. Or frictional force is always in the direction opposite to the motion. In all the questions so far on inclined plane, we are considering sliding down. So friction up, but this time we are finding what force required to move it up the plane. See, in a road, if you place, when you try to move up, you have to overcome 2 things. You have to overcome gravity and also you have to overcome friction. So now friction is like this. See, the block is on the verge of moving up the plane. So friction is down the plane. Make a note here, last here. Therefore, the frictional force is down the plane. You should write if you are in serious. Okay, now start. Sigma Fy0, now simple. Plus R minus 800 sin 65 equal to 0. R will come. Sigma Fx0 plus P minus 0.35 R minus 800 cos 65 equal to 0, you will get the value of P, 591. Now negative cannot come, 591.861. Now, if I am solving an examination, see, what I will do? I will not bother about the sliding or. I know that the force you are applying, see, up the plane should overcome two things. One, overcome gravity. Second one, it should overcome friction also, because friction is reversed now. So what I will do, if I am solving examination, I will not see there. Weight 800. 800 into sine, if this is 25, that is 65. Sine 65 is a normal reaction. Into 0.35 is the frictional force. Plus 800 into cos 65 will give the combined answer 591.861 Newton over. See, that's all. I will not use the pen, only calculator. But you don't try all those things. Okay, now today's class I am concluding. I had done 5 interesting questions. Now I decided. See, everything I did systematically, so many questions. Friction, even though structural engineering point of view, not all these questions are not that much important. I want my class to be a permanent reference in future for those, not only for structural engineers, but also for students studying examination, for example, competitive examinations. Therefore, I decided friction also, I will do so many questions. Those who are interested only in structural engineering, practical design, you can skip so many questions. But study, no problem. So, I told earlier, even though my channel is KSN Structural Engineering channel, but this course I am making, I written there, see, complete and systematic course, so that anybody, for everybody, students writing academic examination or competitive examination or civil service examinations or structural knowledge, everything, my class should be useful. Therefore, over now, this questions over now. Next class, I will continue more questions. Okay, we will meet next time. Thank you.